right, so here's a chart of some common acids. So you need to be able to know this chart because you need to be able to know the strength. So here's the chemical name. So if we were naming our formulas, this would be the name. And you're going to learn how to do this. We're going to talk about in the next couple of slides how to go from the name to the formula and the formula to the name. We talked about how to do this in ionic compounds and molecular compounds. And I said the only thing we had left was to do acids and bases, which we would do in the next upcoming chapter. So now that's where we're at. So here's the names. You'll see they all end in acid. And here's the formulas. They all start with an H. There's a lot of different uses for acids. So some of these are explosives. Some of them we can use to eat or preserve our food. Here's a food preservative, vinegar. We drink some of it, soda water. We drink carbonation. Some of it we can put in our eyes and it won't hurt us. So there's some good benefits, but then there's some things that will like eat up the glass or metal and then are really strong that we don't necessarily want to eat. We don't really want to put like battery acid in our bodies. Here is our strengths. You need to just have this memorized. So you can't just look at a formula and know the strength. You actually have to just have these acids and bases memorized. So you have to know which ones are strong, which ones are moderate, and which ones are weak. Okay? So this chart you need to have memorized. And then here's my common bases. So same thing, here is my naming, and then here's my formula. Now you actually already know how to name bases because bases are just ionic compounds. So you would name this just the same way as you would do an ionic compound. The name of the metal, and if it's a transition metal, you'd have to put it in Roman numerals after, and then the name of whatever the polyatomic ion is or the anion. So some of these have common names. You might have heard of lye before. You might, baking soda, ammonia. So some of these kind of have common names versus the chemical names. But we always wanted to be able to go from the name to the formula, formula to name. So I won't be reviewing this because you already know it. We did this previous. Let's look at some uses. So this is soap. Like we use that one. Here's some more soap. Cement. We can use it with cooking or if our stomachs are not doing well. For cleaning purposes, something that's a little stronger depending on what we're trying to do. Now, you might say, well, wait, this is a little bit stronger, but it's the weak. So remember, we're not going to correlate the strength of what it does with the strength here. When we say strength here, we're talking about how much does it dissociate. So if I say it's a strong base, that means that this formula is going to separate completely into Na plus and OH minus, into the ions. So strength doesn't mean how bad it is for us. It means how much does it separate into ions versus say as the molecule. Okay? So these are strong bases, these are weak bases. So you need to have those known. So the next thing we want to talk about is, well, how do I name an acid? Okay? So if I have an acid, I have a certain way of categorizing my acids. So we already said that acids, the formula is going to start with an H. Every acid has an H. The second thing is going to determine the type of acid. I have two different types. I have binary acids and oxyacids. Remember we talked about oxyacids when we were drawing our Lewis structures? And I said if it's an oxyacid, the H goes on the O. Now we're coming back around to that. Okay? So, acids contain the H plus cation and an anion. The anion determines the category. Okay? So I have two categories. The first is my binary acids. So binary acids have H plus, because everything is H plus cation, but the anion is just a nonmetal. So it's a nonmetal anion. So here you're only going to have two elements. You'll have H plus and then a nonmetal. Fluorine, chlorine, bromine, iodine, some sort of nonmetal. So only two elements. The second type are oxyacids. They have the H plus cation because everything has that. But instead of it being a nonmetal anion, their anion is going to be a polyatomic, polyatomic anion. So you're going to end up having more than just two. Because remember, polyatomic means multiple atoms. So you'll have the H and then a bunch of different elements here. Most of the time, these polyatomic ions contain oxygen, and that's where we get the name oxyacid from. All right, so let's start practicing how to name things. So the first thing we want to start practicing are binary. So let's start naming binary acids. So if I gave you the formula, can you do the name? So binary acids, remember this is H plus and my non-metal anion. So the first thing I'm going to do is write hydro, which is my prefix. This kind of stands for my H plus. Then I took the non-metal, whatever its name is, and I take the non-metal stem. So if it's chlorine, it's chlor. If it's bromine, it's bro. And then I add ic, the ending ic. This ends up being one word. So I have the prefix, the non-metal stem, and the ending ic, and then I add just the word acid. So that's how I name my binary acids. So let's do an example. So this says to name HCl. So first let's start, how do I even know what this is? So I see the AQ, so the AQ tells me this is an acid. So if you see the AQ, that's how you know we're in the world of acids and not ionic compounds and molecular compounds from our previous chapter, chapter 4. Okay? So now I know it's an acid, now I have to figure out what kind. Well, I have hydrogen and chlorine. I only have 2 elements. So if it's only 2 elements, then it means it has to be a binary acid. So now that I know it's a binary acid, now I can use my binary acid name rules. So I know it's always going to be H+, so I got to figure out what the anion is. So the anion is chlorine. So to name the ending, I take the stem of chlorine, which would be chlor, and then I add the ending ic, so chlor-ic. To represent the H, I need the hydro, so hydro, chlor-ic, and then the word acid. So hydrochloric acid. So this is how we name binary acids. So hydro, the stem of the non-metal, chlor, the ending ic, and then the word acid. All right. Next we want to do oxyacids, but to keep my lecture videos shorter, I'm going to break this apart and I'm going to do oxyacids on the next lecture.